So today we are going to discuss the factors affecting the rate of adsorption. In the similar way, you have already studied these factor affecting the rate of the reaction in 270 or 170 as well. Okay? Now specifically we are going to study the factors, different factors which are going to affect the adsorption, because this is very important. And here I have shown a simple reaction. That means it is the adsorbate plus adsorbent. Adsorbate is the which is going to adsorb. It may be a liquid or the gas, and adsorbent, that was in case of it is the solid, it is the surface. And when the both are going to be adsorbed, it will form the adsorption complex. And this is the adsorption isotherm we have already discussed. This is the actually the the rate is fast at the state, then it is going to be inclined, and then it will remain constant when adsorption complex is formed. That means when there is no further spaces are available, then there is no change in the adsorption. So what is the rate of adsorption? Rate is the simple terms. You already know this is the change with respect to time. Change in any property with respect to time. And here the change is the adsorption. So that means amount of adsorbate, which is the number of molecules of the gas or the liquid which are going to adsorb per unit time. So here the change is actually it is the adsorption of the adsorbate on the adsorbent per unit time. That is called the rate of the adsorption. In the next class, we will discuss, we will further explore actually what is this rate of adsorption. But right now, we are going to discuss the factors affecting the rate of the adsorption, and there are the 5 or 6 I have mentioned here. So the first one is the nature of gas, surface area, heat of adsorption, effect of temperature, and the pressure. They are very similar to the already knowledge you have to study the rate of adsorption, but it is going to be different in some of the perspective we are going to discuss in this class. The first one is the nature of gas. See? इसलिए कहते हैं आप जो पीछे आपका नॉलेज है अगर वो अपडेटेड है देन यू विल लर्न मोर एंड इन डेप्थ इन हायर क्लासेस जो है सही दैट्स व्हाई वी प्रेफर you have the prerequisite of this, and then you will be able to understand this one course. The factors are the same, but of course their influence or the understanding it would be a different, because now we are going to discuss the rate of the adsorption. So first one is ये ग्राफ भी आपको जो है 270 में हमने पढ़ा हुआ है. This is the phase changes with respect to solid, liquid, and the gas. Now we are going to apply. This is the application of this graph in this class, or the understanding of the adsorption phenomena with the nature of the gas. Nature of the gas means some gases are easily liquefiable and some are not easily liquefiable. So how they are going to affect the adsorption? So here, if we are considering the nature of the gas, that means the gas is the adsorbate and the solid would be the adsorbent. So how it is going to adsorb in case of the physical adsorption and chemical adsorption. So we will discuss the both processes over here with respect to each of the factors which we will discuss here. The first one is the nature of adsorption. So it is written here, the more liquefiable gas is more readily it will be adsorbed on the surface of the adsorbent. कि जितनी ये liquefiable ज़्यादा होगी उतनी ही ये ज़्यादा adsorb होगी. So what does it mean? It is a more liquefiable mean which is having the more or higher critical temperature. So what is the critical temperature? That's why I have highlighted over the same phase diagram over here, solid, liquid, and gas. So this is the critical point. I'm not going to discuss in detail, but I will just highlight which is more relevant to your this lecture. So this is the critical point. That means the temperature at this point is the critical temperature and the pressure at this point is the critical pressure. So what is the critical temperature? It is also defined over here. The temperature beyond which gas cannot be liquefied. That is the critical temperature. What does it mean? So here you have a look. This is the clear phase between this gas and the liquid. So at this point, beyond this point, no, there is no differentiation between the liquid and the gas. That means you cannot liquefy the, sorry, you cannot liquefy the gas after this point. That means this is the critical temperature. So how the gas having more critical temperature will be more adsorbed on the surface of the adsorbent. So after the that means at high temperature gas still has the ability to liquefy. That means it will be more adsorbed. अब आप इसको जरा देखें ग्राफ को जो है कि अगर ये क्रिटिकल टेम्परेचर जो है वो आपके पास हैंग हो जाए critical temperature, if some of the gas having less critical temperature as compared to here, then the phase between the gas and the liquid will be less as compared to it is shown over here. ठीक है, तो जितना ये कम होगा उतना ही इसमें this is having the less tendency to liquefy. जितना extent ज़्यादा है, that means it is be liquefiable at the high temperature. So जितना temperature ज़्यादा होगा, critical temperature ज़्यादा होगा, उतना ही it is going to be absorbed more on the surface of the adsorbent. And here are the three examples are mentioned over here. Let's suppose if the critical temperature is 157 and this is sulfur dioxide, it is also a gas, and then 380 ml of this is going to absorb on 1 gram of the activated charcoal. So we have taken 1 gram of activated charcoal as a adsorbent, and we are going to absorb 3 of the gases. So sulfur dioxide is going to absorb more as compared to the methane, and methane is going to absorb more as compared to the H2, because sulfur dioxide is having more critical temperature. यही आपको define है. More critical temperature, more will be absorbed on the surface of the adsorbent. And of course, the critical temperature of methane is less as compared to the. So critical temperature of the methane is less as compared to the sulfur dioxide. That's why only 16 ml is going to absorb on the surface of the adsorbent. And in case of the hydrogen gas, it is only 4.5 ml. And why it is? The critical temperature is only minus 240 degrees Celsius. So this is minus 240 degrees Celsius. So this is the effect of the nature of gas on the surface of the adsorbent. Let's wait for